Hey everyone, Mr. Mannix here. Welcome to our lecture on pulleys. This is again going to be a two-part video. The first part is going to talk about pulleys in general, and the second part will go into calculations on pulleys. So, let's get started. What is a pulley? A pulley is a type of simple machine with a wheel and axle that has a groove around the outside. It needs a rope, a chain, or a belt around the groove to make it do work. Pulleys in general can be used to increase the amount of force we can apply to an object. They can also be used to change the direction of force we apply to an object. We don't see pulleys as much anymore as we used to. They used to be very, very common. I know that on our ranch at home we had block and tackle, which is a type of pulley, huge blocks and tackles and ropes that were used to, say, pull tractors out or trucks out if they were stuck. The ancient Egyptians used pulleys to build the pyramids and erect huge obelisks and other monuments. And they really are amazing tools, but they're still around. For example, if you were to go hang an elk in someone's garage, there's a good chance you might see a pulley, such as the one on the screen right here. Here you can see the groove around the wheel, which would be right here. And this would allow you to lift a lot more weight than you ever could without this pulley. However, this one, you can't really see the inside of it very well, so we're going to look at some different examples to learn about pulleys. So first of all, the first type of pulley is a fixed pulley. And by that means that this pulley is fixed by this string or rope to the ceiling here. It can't move. So this pulley would change the direction of the force you applied to it. So you would pull down on the rope here, and this box would be lifted up. It would change the direction of your force. However, this would not increase or multiply your force in any way. And the reason why is that there's only one rope pulling on this box. If you put say a force of 50 newtons on this rope, that force will be transmitted throughout this whole rope. The tension will be 50 newtons. And because the tension would be 50 newtons in the rope right here, it would put a force of 50 newtons upwards on that box. So the mechanical advantage would essentially for this lever be 1. It would multiply any force that you put into it by 1. All right, now a movable pulley. This pulley is not fixed to the top. You'll see the string is fixed up here, but the pulley itself is not fixed to the top. It can move. So as I pull upwards on this rope, this whole pulley is actually going to move upwards. This does give you some mechanical advantage. In fact, the mechanical advantage of this pulley would equal 2. It would double your output force, at least if it was a 100% efficient ideal machine. So your ideal mechanical advantage of this pulley would be 2. Why is that? Well, let's look at this. Let's say I apply a force of 10 newtons on the rope upwards over here. Again, that 10 newton force is transmitted throughout the whole rope. So there's 10 newtons of force in the string here, there's 10 newtons of force in the string here, and in both cases, that tension is going to pull upwards with a force of 10 newtons on that pulley. So there's going to be a total of 20 newtons of force pulling upwards on this pulley. But we don't get something for nothing, so what's the catch? Well, I'm going to have to pull this rope twice as far as the pulley lifts. So how does that work? Let's erase a few of these lines here. Okay, let's say that I was going to pull this rope a distance of 10 centimeters upwards. That shortening that is going to come out of both sides of the rope. In other words, the rope will come up over here by 5 centimeters, and this whole section of rope over here will also shorten by 5 centimeters. So while the whole rope goes 10 centimeters in this direction, this pulley would only lift 5 centimeters. So just like with our lever examples, the total amount of work done doesn't change. You have to apply a smaller force but over a larger distance. So how do we estimate the mechanical advantage of a whole bunch of different pulleys. The easiest way is to just look and see how many ropes are actually pulling upwards on your object. For example, in this lever, there's still just one rope pulling upwards on your object, and we have one fixed pulley. And remember, a fixed pulley does not increase your mechanical advantage. It only changes the direction of your rope. So this whole setup here has a mechanical advantage of 1, an ideal mechanical advantage of 1. If there were no friction, it would take the exact same amount of force on the rope to lift this object. This one, however, is a movable pulley, and it does increase your mechanical advantage. We have 2 ropes pulling upwards, so this has an ideal mechanical advantage of 2. It would double the force you applied to an object. And this is saying that if I wanted to lift this weight, I'd have to apply a force half the size of that weight to lift it. Okay, what about this pulley? Well, I've got one movable pulley and one fixed pulley. This is the fixed one that I'm circling here. So this one is fixed, and it does not increase your mechanical advantage. This pulley is movable. It will raise up as you pull on this rope, and it does increase your mechanical advantage. So the total mechanical advantage for this one, the ideal mechanical advantage, is again 2. Okay, this pulley simply changes, the fixed pulley simply changes the direction of my force from pulling down to lifting the object upwards. There are only 2 ropes pulling upwards on the weight, and therefore this would have an ideal mechanical advantage of 2. Again, you're going to have to pull the rope twice as far as the object lifts. So, pulleys are used to gain mechanical advantage, trading the amount of rope you have to pull to lift an object for how heavy the object can be. So the more times you wrap ropes around pulleys, the more force you get out, but the more rope you're actually going to have to pull out to move the object any kind of distance. All right, let's look at the mechanical advantage of each of these. This has a mechanical advantage of 2. There's one movable pulley and 2 ropes pulling upwards, so mechanical advantage of this one equals 2. This one actually has 1, 2, 3 ropes pulling upwards. This would have a mechanical advantage of 3. Both of these ropes pull upwards, and the force is actually going upwards here. So that has a mechanical advantage of 3. How about this one? In this one we have a rope that coming down here, going up, down, around, and back up. There's actually 4 ropes pulling upwards. This one, this one, this one, and that one. So there's 4 ropes pulling upwards. This has a mechanical advantage of 4. This one has 1, 2, 3 ropes pulling upwards. Mechanical advantage of 3. This one has 1, 2, 3, 4 ropes pulling upwards and 1 pulling down. So it still has a mechanical advantage of 4. And this one has 1, 2, 3, 4, 5 ropes pulling upwards. Again, the difference between this pulley and that pulley is that the last rope here is pulling down, so it's not pulling up on it, and the last rope here is pulling up. It is pulling up on it, so mechanical advantage of 5, mechanical advantage of 4. So an interesting thing about pulleys always have a mechanical advantage of 1 or greater. They can never have an ideal mechanical advantage of less than 1. They might have an actual mechanical advantage of less than 1 if there's a lot of friction, but the ideal mechanical advantage is never less than 1. It can only be used to increase the force you apply. All right, so pulleys don't have to look the exact same all the time. This is actually an example of a pulley, one that we're going to use as a demonstration in class. Basically, if you look at this, if you pull on this rope, there would be 1, 2, 3, 4 ropes pulling this stick towards that one. So this would have a mechanical advantage of 4, and somebody pulling on this rope, whatever force they put on the rope would be multiplied by 4 when they tried to pull those 2 sticks together. All right, so what did we learn about pulleys? 1, they can be used to change the direction of motion. 2, they can be used to increase force. We know that a Fixed pulley does not increase mechanical advantage. And we know that a movable pulley does increase mechanical advantage. And finally, maybe one more important point, we know that to determine the ideal mechanical advantage, count the number of ropes pulling upwards. All right, that is our part one of our lecture on pulleys.